Hello, welcome back to section 5.1. We are doing part 2, and we are picking up with this problem, example number 3, and we're working with IVT and MVT. Our biggest question is which one to apply, right? So I'm trying to get you familiar with that. The function g is a differentiable function for all values of x. Select the values of g are given in the table. Is there a time c between 0 and 6 such that g prime of c equals 2? What do you vote for? Do you think we're going for IVT or MVT? Well, since I see G prime, and back here I saw just G, we're talking about the slope, right? The slope of G. So I am thinking MVT. So I'm going to gear up and get ready for that. Is there a time C? So is there a time? I don't know. I need to find out. So what do I know? I know that g of x is differentiable. So I'm going to state that. I'm also going to state the fact that g of x is continuous. So MVT applies. Yep, MVT applies. And now let's see if we can find a rate of change that's equal to 2. So what I need to do, I need to find where the derivative equals 2. And I need g prime. They're working with the g function, aren't they? I need to find g prime of c equal to g of something minus g of something over b minus a. Let's do b minus a. Now, when I go up to my table and I want this to equal 2. And so I go to my table and I'm going to play with some values. Mainly, I'm going to start with the endpoints suggested. And so I'm going to look at g of 6 minus g of 0 over 6 minus 0 and hope that maybe that comes out to be a 2. So in my mind, this is still kind of all questioning whether this is actually going to work out. G of 6 is 10, g of 0 is negative 2. Watch that double negative. Over 6, 2 equals 12. 12 divided by 6, 2 equals 2. Yes, there is a time where g prime of c equals 2. And I was able to find it the mean by the mean value theorem. And all my work is there to substantiate my claim. I attacked the hypothesis, and then I looked at what the conclusion stated, and I was able to find that moment when it does equal. So good deal. Example 4. The function f prime is differentiable for all values of x. Selected values of f prime are given in the table. Can you guarantee a time between 2 and 15 such that f prime of k equals 5? Give a reason. So, do you think it exists? Is this MVT or is this IVT? Well, look there. They match up, don't they? And when those functions agree, it's most likely going to be IVT. I'm thinking IVT on this one. The IVT will guarantee this for us if we meet the conditions, right? So basically, 5 has to be between, one place to check would be our endpoints. From 2 to 5, or 2 to 15, I'm sorry, we get 2, 1, and 15, 6 as our ordered pairs. 5, the y value sits between 1 and 6, so everything's looking like go ahead. All right, so we can say yes, f prime is differentiable. So f prime of x is continuous. Continuous is the requirement for IVT for all values of x on 2 to 15, and f prime of k equals 5 is between f of 15, which is equal to 6, and f of 2, which is 1. If you want to make it really obvious, you could go 1 to 5 or 1 to 6, right? And therefore, whoops, didn't finish my word. Therefore, by the IVT, a C on open interval 2 to 15 exists where f prime of C, they use K, I use C, equals 5. Okay. That's all we need to do on that one. Example 5, the hours 0 to 8. Notice those are our endpoints. The rate, okay, they're talking about rate. The rate that people leave a museum can be modeled by the differentiable function L prime. All right, makes sense. A rate and L prime, that matches up. Where L prime is measured in people per hour. Selected values of L prime are given in the tables. Do the data in the table support the idea that L double prime equals 0 for some value C on 0 to 8? Give a reason. Okay, so they're moving to L double prime, right? The derivative of the given function. That sounds like MVT to me. So, because I'm in my head, I'm comparing the request for L double prime of C when given L prime of T. To me, this is indicating MVT. We need to get another derivative taken, right? So, is the function differentiable and continuous? Well, I see the word differentiable. So, meets the hypothesis. Now, is there a spot where our table lends itself that we do indeed get a slope of 0? I'm going to check out those endpoints first. So I'm just kind of doing a little preceding check out endpoints because I want to know if I can get a slope of 0. My endpoint, L prime of 8 minus L prime of 0 over 8 minus 0 turns out to be 6 minus 6 over 8. 0 over 8 equals 0. The average, you know what? Let's write this. There is an A rock out there on this table such that it is 0. So what does that kind of tell me? You know, when we were doing those curves yesterday and we had some sort of curve and we connected up our endpoints, we just found that the A rock on this curve was 0. And if I have a continuous differentiable function that I'm working with, why is that disappearing? I don't know why that does that. Yeah, if we have that A rock, then there has to be another spot along here, some value C, where I rock equals A rock. So yes, I know this is going to exist. I've checked it out. So let's just answer the question. Give a reason. Do the data in this order. Yes. L prime of T is differentiable. Let's hit that hypothesis first. Is differentiable on 0 to 8. Oops, closed. And L prime of T is continuous on 0 to 8. MVT applies. And we notice that L double prime of C will equal L prime of 8 minus L prime of 0 over L, not L, 8 minus 0. That turned out to be 6 minus 6. I'm just going to bring that work that we had done. That's an 8 before. So yes, L prime is differentiable. And yes, there is a C on open interval 0 to 8, such that, because I just want to make sure I answer the question, that S or L double prime of C equals 0. I think that covers it. We have some more homework coming our way. This was day 1. I forget if it's, I will look. There is also another, it's all AP questions. So yeah, Delta Math and the worksheet. Make sure you have those two done. Ta-ta for now.